ಹಾಯ್ ಎವ್ರಿವನ್, ಶರಣು ಶರಣಾರ್ಥಿಗಳು. ವೆಲ್ಕಮ್ ಟು ಶ್ರೀ ಬಸವ ಪಬ್ಲಿಕ್ ಸ್ಕೂಲ್ ಇಳಕಲ್. In previous class we have started the new chapter in the physics, that is force and laws of motion. In this chapter we have studied in the first class or previous class. Those are force, effects of force, balance force and unbalanced force. So along with we have studied that force of friction, their example. Okay, now today we will discuss the new aspect in this chapter, that is Galileos experiment of motion of an object on an inclined plane. So here you observe here A and B are two inclined planes are there. So we have taken that one marble. So you just observe the graph, the inclined plane of the B1, just you are changing the position, then how this marble can be move in the inclined plane. So this one is shown by Mr. Galileo Galilei in his experiment. So that experiment is shows in the inclined plane. Now my dear students, so listen here. When a marble rolls down an inclined plane, its velocity increases, and when it goes up on the second inclined plane. So here how many inclined planes are there? Two are there. We can kept in the opposite position. So in the first inclined plane you roll the, just you observe the arrow mark, roll the marble, so it will be moving in the first inclined plane, and next it will be increase their velocity in the second inclined plane. It is the first graph showing. Its velocity is decreases when if the inclination, see in the second inclined plane the velocity will be decreases. So once again you listen here. When a marble rolls down an inclined plane, its velocity increases, and when it goes up the second inclined plane, its velocity decreases. Now clear? Okay. If the inclination of the both the planes are equal, then the marble will reach the same height which it rolled down. So because both the inclined planes are in the equal position, then the marble will be in which height can be you roll down, the same height can be takes place in the second. Okay, or second. If the inclination of the second plane is decreased, it will be travel more distance to reach the original height. If the inclination of the second plane is made horizontal, the marble will be travel forever, so trying to reach the same height, and an unbalanced force is required to change the motion of the marble, but no more is needed to sustain the uniform motion of the marble. See, from this experiment we concluded that if the position of the second inclined plane it changes, so we can see the motion of the or velocity of the marble will be changes. So it means that which force can be required to change of the motion here? Unbalanced force. In the previous class we have discussed that what do you mean by unbalanced force. So again I will revise here. If two forces act on a body in opposite direction, and if one force is greater than the other, then we can say that unbalanced force. Yes or no? Yeah, in the previous class F1 is greater than F2 or F2 is greater than the F1, we found that equation. So like that here also, which one is needed or required to the change of the marble in the force? No force are sustaining in the uniform motion. Here unbalanced force is required. So along with this experiment we can see one animation video also. Okay, fine. So next I think this experiment understand along with the picture. Okay, my dear students, thank you.
He also performed the inclined plane experiment, in which the two frictionless planes were inclined to horizontal table and a ball is pushed from a height by a slide force of hand. The ball rolls down, climbs the another inclined plane and reverses the direction of motion. How far does this ball move up at the another surface? Well, since the slopes of two planes are equal, if we have the look at the height at which the ball has reached, we see the height of both the points is same from the horizontal table level. So, the ball moves to the same height from where it was released. Now, let's decrease the slope of the inclined plane on the right. Release the ball again. What do you see? It has reached the larger distance to reach the original height. Now, what would happen if the slope of inclined plane on the right is eventually reduced to 0? So in this case also you have already seen that the ball has reached a larger distance but has reached the original height. And now, if the slope is eventually reduced to 0 and it is made horizontal, do you know what will happen? The ball will continue to move forever trying to reach the original height. Now, what would happen if inclined planes are inclined in such a way that h1 is greater than h2? The yellow line here shows the difference in height in these two levels. If a ball is released from this height, it will try to reach its original level. Well, and what happens if there is no inclined plane up to that level? Well, the ball will fly in a parabolic path from the extreme of the another inclined plane. So, make sure when you go to a U-shaped slide in water park, the two levels are equal. Galileo was concerned with how things move, rather than why they move. He showed that experiment rather than the logic is the best test of knowledge. Also, a series of experiments lead us to some basic conclusion. If the slope of surface is downward, the speed of the body will increase. And if the slope is upwards, the speed will decrease. Then, if there is no slope, does speed change? This is what we have just seen from the Galileo's inclined plane experiment. That, if the initial position and final position we see here shown in the diagram, if we decrease the slope, the initial and final position are at the same height from the horizontal level. And if there is no slope on the right side, so where is the final position?
Okay, this is the new slide of this chapter, that is Newton's law of motion. There are three laws of motion Newton has given in this chapter. Here first one is Newton's first law of motion. It is also called as laws of inertia or law of inertia. Now I will give the statement of this first law. So Newton's first law of motion states that an object remains in a state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. So here one picture has given. See here, the index card is there, then coin and glass. So here the coin is in the inertia. When you apply the force, the coin is fall in glass. Okay, because an object remains in a state of rest. If you apply the force, the object can be changed their position. Okay, so once again you listen carefully here. What is the statement? An object remains in a state of rest or in uniform motion in a straight line. If you applied or unless compelled to change that state by an applied force. So here we are applying the force. Due to the force, the object is rest in position, it can be changed the position or moving. If the object is in the uniform motion in a straight line, it is also change the direction, because you have applied the external force or only force. Now it is also called as inertia, the natural tendency of object to remain in a state of rest because of force or in uniform motion is called inertia. Here the natural tendency of object remaining in the rest in position because of inertia. If the object is a continuously uniform motion by applying the force, it is also called as inertia. So this is why the first law of motion is called law of inertia. We can see their example in the next class. Example of inertia we are discussing in the next class. Okay, so thank you once again. Sharanu Sharanarthigalu. Thank you once again, my dear friends.